Deep beneath the Swiss Alps, there's a modern marvel, a testament to human ingenuity and perseverance. It's not a towering skyscraper or a sprawling city, but something buried deep within the earth, a ribbon of steel and concrete that redefines what's possible. This is the story of the Gotthard Base Tunnel, the longest and deepest railway tunnel in the world. For centuries, the Gotthard Pass has been a vital but treacherous route through the heart of Europe, a formidable barrier of granite, snow, and ice. It challenged traders, travelers, and armies alike. As far back as the 13th century, people dreamt of a better way to cross these mountains. The first major breakthrough came in 1882 with the opening of the original Gotthard Railway Tunnel. At 15 kilometers long, it was a sensation, a true wonder of its time. But as the 20th century progressed and Europe's economies grew, this Victorian-era tunnel, along with the winding mountain roads, became a massive bottleneck. Trucks clogged the highways, and the old railway line, with its steep gradients and tight curves, was slow and inefficient. Something had to be done. Switzerland, a nation at the crossroads of Europe, decided to take on a challenge of epic proportions. The vision was audacious, to drill a flat, straight tunnel directly through the base of the Gotthard Massif. This wasn't just about making travel faster, it was about protecting the pristine alpine environment from the ever-increasing truck traffic. In 1992, the Swiss people voted overwhelmingly in favor of the project. It was a massive commitment, a project that would take decades to complete and cost billions of francs. The plan was set. They were going to build the Gotthard Base Tunnel. So, how do you even begin to build a 57-kilometer tunnel through one of the mightiest mountain ranges on Earth? You can't just start digging from one end and hope to meet in the middle. The project was a masterpiece of logistics and engineering. The tunnel is actually two separate single-track tubes connected by cross passages every 325 meters for safety. To speed up construction, the tunnel was divided into 5 sections, with work starting simultaneously from multiple points. This meant digging not just from the north and south ends, but also from intermediate access points deep within the mountains. The real stars of the show were for colossal machines, the tunnel boring machines, or TBMs. These weren't just drills, they were mobile factories, over 400 meters long, crawling through the rock. We can call them Sissy, Heidi, Gabby 1, and Gabby 2 named, as is tradition, after female saints or prominent women. At the front, a massive rotating cutter head, studded with sharp steel discs, chewed through the mountain. As the TBM inched forward, it would simultaneously excavate the rock, carry the debris away on a conveyor belt, and line the newly dug tunnel with precast concrete segments. It was a continuous, relentless process. But the mountain didn't give up its secrets easily. The engineers faced immense challenges. The rock types varied dramatically, from solid granite to soft, crumbly rock that could collapse without warning. One of the most difficult sections was the Piora Fault Zone. Geologists feared this area contained a type of rock as soft as sugar, under immense pressure, which could have flooded the tunnel and brought the entire project to a halt. The tension was incredible. For years, engineers drilled exploratory boreholes, trying to understand the exact conditions. Fortunately, they discovered the fault zone was much more stable than feared, and the TBMs were able to pass through it. But it was a heart-stopping moment for the entire team. And then there was the heat. Deep inside the mountain, with up to 2,300 meters of rock overhead, temperatures soared to over 40 degrees Celsius. It was like working in a sauna. The conditions for the thousands of miners, engineers, and technicians were extreme. They worked in shifts around the clock for years on end, deep beneath the Earth's surface. This was a human endeavor as much as it was a technological one. It required skill, bravery, and an unwavering belief in the project's vision. On October 15, 2010, after years of relentless digging, a historic moment arrived. The TBM, named Sissy, drilling from the south, was just meters away from breaking through to the section being dug from the north. The world's media gathered to watch. Live on television, the giant cutter head crunched through the final layer of rock. A tiny hole appeared, then grew larger. A worker waved a Swiss flag through the opening. It was a moment of pure elation. The two ends had met with a precision of just a few centimeters. The Gotthard Base Tunnel was physically complete. It was a flawless breakthrough, a perfect fusion of planning, technology, and human effort. But breaking through was just the beginning of the end. The raw, rocky tubes now had to be transformed into a high-tech railway. This phase was just as complex as the excavation. Thousands of kilometers of cables had to be laid. Tracks were installed on a bed of concrete to allow for high speeds, and sophisticated signaling, ventilation, and safety systems were fitted. Every detail was meticulously planned to ensure the tunnel could operate safely and efficiently for the next century and beyond. The sheer scale of this fit-out phase is mind-boggling. It was like building a 57-kilometer-long smart city hidden inside a mountain. Finally, on June 1, 2016, the Gotthard Base Tunnel was officially opened. The inauguration ceremony was a grand affair, attended by European leaders who arrived on the first official trains to pass through the tunnel. It was a celebration not just for Switzerland, but for all of Europe. The tunnel was now open for business. So, what does this engineering marvel actually achieve? First, speed. Passenger trains now zip through the tunnel at speeds of up to 250 kilometers per hour. The journey time between Zurich and Milan is cut by about an hour. What once took a full day of arduous travel over the mountains now takes just a few hours by train. It's a game changer for travel and commerce between northern and southern Europe. But the biggest impact is on freight. The tunnel was designed with a very gentle gradient, making it almost completely flat. This means freight trains can be much longer and heavier than the ones that used to struggle over the old mountain route. A single train can now carry the equivalent of 260 trucks. This is the heart of the project's environmental vision. By shifting massive amounts of cargo from road to rail, the tunnel significantly reduces truck traffic, cutting down on pollution, noise, and congestion in the fragile alpine valleys. It's a powerful example of how smart infrastructure can promote sustainable transport. The Gotthard Base Tunnel is more than just a hole in a mountain. It's a symbol of what we can achieve when we think long-term, when we invest in ambitious infrastructure, and when we work together across borders. It's a story of connecting people, boosting economies, and protecting the environment. From the early dreamers who looked at the Alps and imagined a better way, to the thousands of workers who toiled deep within the earth, this is a legacy carved in stone. The next time you think of epic human achievements, don't just look up at the sky. Sometimes, the greatest wonders are hidden deep beneath our feet. Thanks for watching. If you enjoyed this journey, don't forget to like, subscribe, and hit that notification bell for more stories of incredible engineering.